So lesson 5.3, we are going to take just a few moments to touch on evaluating algebraic expressions. Incorporated this is also the use of order of operations. We have to bring those back in when we're evaluating algebraic expressions. But when you get done here, your job is to be able to evaluate algebraic expressions. That is the goal of this particular lesson. So first of all, we need to hit on a couple of vocabulary terms. First of all is the idea of a variable. And by definition, you want to get this down. A variable is a letter or symbol representing a quantity that can change or vary, taking on different values. Now, that is typically the expression that a lot of people get when they use, when they see the term variable, or at least when they see the definition of variable. And one of the things I want to point out at this point is people make the idea of a variable much more challenging than it actually is. The reason I say that is because you have been using variables since you were in, about kindergarten, first grade or something. But in those times, or back in the day when you were using them in different format, you would use your variable in that case would be box. 3 plus box or blank, however you want to put that, equals 12. And your job would have been to figure out what is the value that goes in the box. When we get into algebra, typically we will use letters. So instead of using a box, we will use an X, for example. So our job a lot of times is to figure out, well, what is the value of the X? Obviously, in this case, it's 9. And not that I want to worry about what is that value right now. But another format that you would possibly use in the past is the idea of blank. So 10, and this X right now is actually being used as a multiplication sign. And that's one of the things in algebra that we try to get away from, is using X as multiplication. So as we go down the road, we will limit and hopefully eliminate the use of X as a multiplication sign. But 10 times blank equals 20. Well, I hope in this case you realize that it's a 2, but that's not the important part here. In this case, when we're using a variable, we might use, instead of using blank, we might use y. 10 times y, 10 times something. Our value in this case is our something. That represents our value that's unknown, equals 20. Or even symbols when you were a child, or more of a child than you are now. You might use something like a star. Star minus 14 equals 5. Okay. Now in algebra, instead of using a star, we would probably use a letter of some sort. In this case, I used G. G minus 14 equals 5. Okay. So the point of all of this is you have been using variables for a long time. You've just been using them for the most part in different formats. Box, blank, star. We're using letters now. It's not that big of a change or difference. So let's not make it out to be harder than it happens to be. One other definition we need to talk about before we go on into evaluating algebraic expressions is that of a coefficient. Okay, fancy term for this. A number multiplied by a variable in an algebraic expression. Algebraic expression. An expression that contains at least one variable. 30n is an algebraic expression. Why? Because it contains a variable. In this case, the variable is n. Okay. In this case, 30 is the coefficient of n. Okay. Why? Because it's the number that's being multiplied by the variable. And how do I know it's multiplication? And this is one thing we just have to remember, is that in algebra, if we have a number and a letter, in this case the coefficient and a letter sitting next to each other without spaces, it implies multiplication. Okay, that's just the way that mathematicians shorten expressions up. We'll take out multiplication signs and so on to simplify the writing and expressing of algebraic expressions. So 30 in this case is the coefficient of n. This means 30 times n. Now understand, 30 actually could be in the back as well. Okay, this could be n30, although typically mathematicians will put the coefficient in the front. It's sort of convention. So, all right, So our steps for evaluating, now we're going to go on into evaluating algebraic expressions. First of all, you need to copy the expression down. If it's not on paper where you can work on it, copy the expression down. If it's already given to you on a piece of paper or something, a worksheet that you can work on, then fine, you can skip step number 1. 2, you are going to replace the variable with a given value. Okay, and I will show you this in a second. Step 3, you will simplify the expression using your order of operations. We reviewed the order of operations in the last section. Okay, so you use your order of operations to simplify things down. And the one thing, and this is something that I want you to make sure that you are doing, is you're showing your steps. Okay, even if you're typing things into a calculator to do, write down what you did to go from one step to the next step and so on. Okay, so here we are. We're going to go through a few examples of expressions, algebraic expressions, and we're given a value to substitute in. So in this particular case, x plus 5, we're going to evaluate for x equaling 11. So the first thing that I'm going to do is I'm going to copy down the expression, x plus 5. Okay, so I have room to work with it. And then I am going to, step number 2, take the value that's given. There we're being told that x is an 11. So I'm going to literally replace 11, or x with 11. And now I can simplify using my order of operations. 11 plus 5 is 16. And yes, I know this didn't have a whole lot to it. Some of the expressions, especially in the beginning, may be relatively simple. As we go down the road, they'll get more complex. So B, we do get slightly more complex. 2a plus 3, okay? And in this particular case, remember that there is no space between 2 and a. 2 is the coefficient, so we have multiplication going on here. So I'm going to rewrite this so I have some space to work with. Okay, and I am going to replace a with 4 in this case. Now I have to keep the multiplication. Now you could use a multiplication sign. A lot of times we will use parentheses. I do that quite often myself. But we do have to make sure, because there is no space, that we keep multiplication. Again, I'm leaving no space here, so multiplication. Now my order of operations, right now I have multiply and I have add. We know in our order of operations, multiplication comes first out of those two operations, so I'm going to do it first. 2 times 4 is 8. Bring down my plus 3. Haven't done anything with it. Now I can go ahead and go 8 plus 3 is 11, and so my solution, when a is 4, the answer here is 11. Now, going back to that definition quickly of a variable. Here, let me flip back right here to variable, and let me bring that back up there. A quantity that can change or vary. Okay. In some cases, I'm going to go back here to B. We may, in another case, say, well, what if a is a different value? Okay, what if a is 7? We could redo this problem with a being 7 instead of 4. So that allows us the flexibility of changing the variable to fill a specific situation. Let's say if we're going to have a dance, and I'm just talking out loud here real quick. If we want to figure out, say it's $5 per student to come to the dance. Well, we don't know how many people are going to come to the dance. So we might say 5 times S, 5S, to represent how much money we will make depending on the number of people who show up at the dance. So if 50 people come to the dance, S becomes 50. 5 times 50 gives us our total. But if only 25 come to the dance, 5 times 25. So using a variable allows us to change the value depending on the situation. So, all right, so 5x plus 2y. Now in this case, so we have two variables going on. And so we will copy it down, and then we'll go ahead and we will substitute in. Now make sure that you do substitute x in for x and y in for y. The number of times over the years I've seen students, and I've even done it myself, accidentally mess up a problem simply because they put the number in the wrong spot. Not because they didn't know how to do the steps, they just substituted in the incorrect place. So be careful of that. All right, so in this case here, I've got multiply, add, and multiply. Now we know multiply comes before add. We're going to do it from left to right. Now because these multiplications are separate, I actually can go ahead and do both of these in the one step. Okay, so, and if you need to, you go to the side. If you don't know what 13 times 5 is, if you have to, you go over to the side or use a calculator. 5 times 3 is 15. 5 times 1 is 5, plus 1 is 6, and you bring your answer back over if you need to. Okay, so if you don't know what it is off the top of your head, but again, I'm showing my steps as I'm moving down the problem. 2 times 11 is 22. Okay, now if you need to, again, you go to the side, you line up 65 and 22, put it in the calculator, or in this particular case, 5 plus 2 is 7. Those are my ones. 6 plus 2 is 8. 87, and I'm completed. So in this particular case, 2 variables going on. All right, and again, 2 variables going on. 2.5 times p minus 4q, and we have our given values of p and q. So let me go ahead and put those in. 2.5 times p, which is 12. 4 times q, which is 6.5. And then we go ahead and multiply out. And again, if you need to, and just for the sake of showing the example, if I don't know what 2.5 times 12 is off the top of my head, I can punch it in a calculator. I can go over to the side like I'm going to do right now. Again, just modeling here. 5 times 2 is 10. 2 times 2 is 4, plus 1 is 5. Placeholder, 1 times 25 is 25. And add those up. So I've got 0, I've got 10, carry, I've got 3 and 1 decimal place. So 2.5 times 12 is 30. 4 times 6.5, well, if I need to, again, I go, now I'd put the 4 on the bottom because it shortens up the problem. 4 times 5 is 20, carry. 6 times 4 is 24, plus 2 is 26. And I have 1 decimal place, so I have 26. So I did my multiplications. They didn't impact each other, so I just did them separately. And I did them in the same step, but I did them separately. Now I'm just left with subtraction, so it looks like the difference of those two numbers, 30 and 26, is 4. So if you need to, go to the side, do the work, bring it back over, punch it in a calculator. But in each case, you'll notice I showed my steps. I can see what I did here from step to step. Your turn to practice your work with algebraic expressions and simplifying. Good luck. Come see me for help.